Hey everybody, welcome back. We're on experiment 15, part 2. And I'll put a qualifier on there. Take 3. I actually, the first time I tried to do this video, I had about 4 different interruptions in the video, and I decided to just scrap the whole thing. And the second time I did this video, I must have somehow oriented the camera so that the video was taken like in this little vertical tall narrow strip, so it wasn't actually like a widescreen video, it was like more like a vertical widescreen, and that was just absolutely awful. So we're going to try this for a third time. So this circuit looks quite a bit different than when we last left off, and we had one basic goal, and that was when an alarm system was armed. If you disarmed it this way, it actually shouldn't disarm that way, because if somebody breaks in, they should not be able to disarm it. So, before we did not have this part of the circuit. We had a little LED, and grab a pen here, and the LED would light up when the magnetic switch is separated, and when you close it, the LED would turn off. In this new world, we have our relay here that we had before, except this time when we trigger it, the relay actually turns into a kind of a little self-sufficient circuit that powers its own coil that allows the relay to be the new supplier of power to the circuit below, rather than anything to do with this part of the circuit. And that's pretty cool. So in terms of parts, we have a new diode here, and this is for backflow protection in case the relay circuit wants to try to send current back towards the emitter pin of our NPN right here, because remember, this stuff's going to turn off at some point. In fact, that's going to turn off when we put these guys back together. So then this area of the circuit becomes the power output towards this part. So when this is the power output part of the circuit, we wouldn't want like current flowing back that way. So we got that out of the way. This part of the circuit is actually kind of my own variation of the earlier oscillating sound circuits that we explored in, I don't know, I have no idea, maybe it was like experiment 10 or something like that. Anyways, and when I say it's my own circuit, that's because I didn't really follow any of the values for resistors or capacitors or anything. I kind of made them up as I went along, just using the basic principles of, hey, I need to make sure I use a put transistor, daisy chained with a normal NPN for amplifying the output of our put, and some sort of capacitor to help reach the voltage thresholds on our put, so that it would then discharge the cap and essentially amplify that output of our put, and then that would actually be audibly recognized through this little speaker here. And what else should we share here? I think I will demo it, and then we will just go over a little bit more of the details, but otherwise it's really not a complex circuit. In fact, I spent way too much time on it, not because it was hard to build, but because I have a new toy. I have an oscilloscope now, and I'm not going to demo it in this video, but I will definitely do a review of it in an additional video. But I actually was, sticking my probes in different parts of the circuit to kind of analyze the the waveforms compared, I was comparing like the discharge of this little cap here with the voltage that was basically hitting our base pin of our NPN right here. And it was pretty cool to see, because it really helped to visualize the frequency that was flowing through the speaker. In fact, this ends up being about 260 hertz when you hear it in a moment, and 260 hertz ends up being just shy of the note C, the 4th octave C on a piano. It's just a couple hertz below that, because I think 262 hertz is the C note on the 4th octave, for all you piano players out there. So anyways, I'm going to dial this up to 12 volts real quick, and we'll take a look. And we are at 12 volt. There we go, 12.0. Alright, so right now we're drawing, I don't know, about, looks like about 10 milliamps. And I'm trying to think why we are drawing any current at all. That mystery will have to go unsolved for the moment, because if this guy is not powered yet, what is drawing current? Not 100% sure. There could be a little leakage that might explain some of it. So anyways, let's open this up. As you hear, that's just about the note C, and we're drawing about 50 milliamps of current right now. So I'm going to shut this, and as you see, the alarm is still sounding. And that's because the relay is powering itself now, and no longer is this part of the circuit in play. So the only way to disarm it for now is to crank the voltage back down. And as you heard at the very end there, the coil in our relay pretty much ran out of voltage to create that field around the coil, and the latch ended up being released, which basically let go of the circuit that was, it was self-powering, which then ended up pretty much cascading all the way through the rest of the circuit to turn off everything essentially, and then the little cap ran out of juice, of course. So that's how the circuit functions. And just to go over a couple more details, let me turn our power supply off. So the way this guy powers himself is the key to this entire experiment. And it's pretty simple. The power runs through our diode, and once it powers up the coil, we have another circuit that gets formed here. We have a path from the negative through the coil down this red line, and the red line actually leads to one of the latch outputs of this relay, and it's connected to this blue line actually, which goes to the positive portion of our power source. So we literally have a new complete circuit running from here to here, and that keeps the coil lit up. So no longer do we need any of that. And once we have this complete circuit running, this resistor taps into that circuit right there. And that becomes our new power supply, at least the positive part of it, to the rest of the circuit. And then you can look and see here that this little ceramic 2.2 microfarad cap is plugged into our ground here. And the rest is pretty much review from before. So that's it, guys. And the last part of experiment 15 goes into pretty much putting this into a enclosure and soldering and all that good stuff. And honestly, I spent way too much time on this circuit, and I'm pretty sick of it. Looking forward to getting into actual IC chip usage in experiment 16. So I am actually going to be moving on, and I will see you all then. Have fun.